Okay, so folks, welcome back. Today we're going to start with some chapter 5 ideas, but before we do that, hopefully we'll get Alex online here. Okay, I'll just say, are you there, Alex? Good, everybody else? Lola, am I missing Lola? Looks like it. Okay, yesterday I showed you a cathode ray tube. Who remembers why is that important? I know it was a little rushed at the end of the hour. Or what it helps show someone that someone used it to help discover something. Discover something. Nina? Right, so it was J.J. Thomson, and he named the particles what? Electrons. So this is the discovery of electrons using the device I showed you. And as you guys came up with the magnet before you left, I hope you realized that even though I put the magnet in like this, the little spot which showed where the cathode rays were landing, what did it do? Even though I came from on the side, it moved either or. And that's the interaction, as you might know if you have AP physics at all, from particles that are in a magnetic field. So charged particles in a magnetic field, we say they're deflected, and they're deflected at 90 degrees to that field. And so we figured, hey, these things have a charge. Alex is there. Good. Okay, I'll try and make sure you can see the board here. Okay, good. Feedback. I graded the rest of all the online quizzes yesterday, and they ranged from people who I think really took it seriously to some of you that really didn't do much of anything on it, which was disturbing. So the average was like 5 out of 12, and if you found it difficult, that's okay. It's AP material, and I know you'd find it difficult. But I was annoyed by a few that didn't really finish it or just said, I don't know. Yeah, okay. All right. So look over the feedback, and I think you can now access the answers. Am I right? Now that I corrected them and sent them back? Thanks, Amina. Okay, so do that. See how to do the ones you could not do. And the one that bothered me the most was the very first one, because it asked you to write a net ionic reaction for making a precipitate. And the precipitate, I think, was PbI2. And some of you just ignored that totally. And you knew what a net ionic reaction was, because you told me. A lot of you got the point for what's called the justification of explaining why you need to do it this way. But a lot of you just wrote all the chemicals. We also did this in lab. So I was shocked that I'd say at least 10 of you did it really wrongly. So if I just write the net ionic reaction, what are the ions forming this? What should be on the reactant side? Yeah, I need chargers. Plus. I minus. Now you got to balance it. Somebody else. Penelope, how can I balance that thing? Well, it is that, but I need the other side balanced also.
Oh, sorry, you put the 2
I minus.
Yeah.
Yeah, you got it. These are aqueous, the others are solid. I don't think you had to have that, but in case you did. Okay. We'll write more of these, but you need to understand that net means don't put in stuff that doesn't do anything. You also had, I don't know, nitrate or whatever, but it doesn't do anything. Don't put it in there. Net means only the actors that are involved, okay? So that's really important. That will be on every AP test from now for the next 100 years. So you have to get that right. It's supposed to be an easy point for you, not a challenge. Okay, that's my lecture for today. So please do better, take it seriously next time. What I'm going to do next time, and I haven't made it yet, but with the online quiz, here it is. I'll give you a deadline to do it. I'm going to have it timed, and I'm going to also grade it in some realm. Okay, so I need you to take it more seriously. Okay, I will grade it on the AP scale. In other words, if you had 50%, that would be like a 2. You know what I mean? So because 50% on the AP scale is probably, well, it's not quite a 4, but I'll probably be nice and do it that way. Okay, so I'll use the AP grading scale, but I think I will grade the next one. Maybe then we take it a little more seriously, at least some of them. I also would like to do a limited reactant quiz. And I want to do a problem right now to show you what that quiz would be like, okay? We did something like it, but let's do one as if it were a quiz so you understand how to do it, okay? All right, so I'll say this would be like an example of limiting reactant quiz format. Okay. I'd probably give you a reaction, so I'm just going to make something up. C6, H14. Okay, and I might say this, if and for 19 halves, you can also write it as 9.5, okay, when you're doing this. So 19 halves can be thought of as 9.5 when you're doing problems like this. Okay, right. If 3.72 grams of hexane, if you got that from template, hexane is mixed with 27.9 grams of O2. Find the theoretical yield of CO2, what we're often concerned about anyway. The what chemical is the limiting reactant? See what chemical is in excess. Okay. So you'll need a periodic table, and you can do this right in your notes. I'm not going to collect it. So periodic table to do this, and we'll give you like 5 minutes, and then let's have you guys put it up on the board. So show your work as you would on a quiz or test. I think you have all you need.
Are you collecting it or not?
No, I'm not collecting it. No, this is a format. So it's not a quiz. It's the way the quiz will be similar to. Okay, let's get something to erase that. Okay. Yeah, yield is usually in grams. So. That's right. I just want to say what it is, what chemical. Okay. Alex's question is it at standard temperature and pressure? It doesn't really matter for this because I give you grams. So if I gave you liters, then it would really matter, but I didn't. And we'll get to using liters with this when we get to our chapter on gases. Okay, so if you haven't done this yet or don't understand what I'm asking for, ask Alicia to do the first part. So hopefully you've gotten that part, but if not, that's half a problem, right? And then you've got to do what she's done also with what other chemical? What other chemical, Mia? With the O2. So you got to start with the amount of O2. So if you now get it, do the O2, please. Then I'll have one of you do the O2 part on board too. Yeah, maybe, but you still have to clearly answer this. Like the work is good, but now you got to give your answer. That would not be helpful. You just have to think about what you got, and you need to give which one is the actual answer. Aha, so you need to do a circle or say it or something, so it's really clear to the data. Well, it's funny.
Oh, because that's the one less.
Yeah. No, O2's double that. That's for one.
Right.
Yeah. So, so far so good. Now keep going. Now you gotta change it up from what? Like we did up here, moles of that to moles of this. Now you gotta go moles of O2 to moles of CO2. If you're interested in CO2. So what? Just remember. Yeah, good. Just put those in there. So instead of 1 to 6, it'll be, or change it to a decimal. Yeah. Okay, good. Thank you. All right. So I hope you're on your way to doing this. You can make these up at home to practice. Just pick a couple of numbers, okay? All right, so both ingredients have been used to see how much cake we could make, right, so to speak. And one we could make 11.4 grams of CO2, the other one I can make a lot more. And in words, how about Chelsea, why is it then this is my theoretical yield?
Because because you only have that in grams, you can't, I mean, I don't know if it's words, but you don't have enough hexane to make more than 11.4 grams of CO2.
That's how you put it in the words. Say that last sentence again.
you don't have enough hexane to make more than 11.4.
That's really the key. So I hope everyone kind of understands what Chelsea just said. So that's, if you understand that, oh, that's the most I can make because I don't have enough hexane to make more. It's a good way to say it. So my theoretical yield is here. You could even write it so the grader's really clear about it. But circling it probably would be enough as well before you go down. Okay, so somebody else, how about Errol? So why is the limiting reactant this chemical? More or less. Yeah, I guess. Could I say it another way? No?
I mean, essentially, hexane is what limits the thing from being able to make more because there's not enough for it to be anymore. So its amount is cutting off how much of the product can be made.
Okay, good. All right. Just getting you all to think about how you want to say it, because you'll all have to say it and write it at different times this year. Okay? And how about Aiden? The chemical in excess, O2Y. Because the O2 theoretically would allow me to make. Okay, so I'll have leftover O2 with that idea in mind that the other is the limiting one. Okay, questions from you? Okay, you tell me your schedule. Our options for the quiz are, what's today? Tomorrow, or maybe Monday's such a crappy day. How about tomorrow or Wednesday? Then that's not a good day. Are you here, some of you, or do you have that clausura during this hour?
No, it's an art clausura, so it's I think it's just 2 hours.
Okay, all right.
3, I'm not sure.
Okay, very well. Do we want to have it then next Wednesday? Okay, so let's make this limited reactant quiz on Wednesday. I think that's the 7th.
Is that going to be like online?
No, that's going to be right here in the classroom. The online I'll do separately. I've got to pick problems. And the problems will be on all sorts of different things that you've done. It won't necessarily just be on this, but on other concepts that you've had now in chapters 2, 3, 4. Okay, but we'll do then classroom. Let's call it a classroom quiz. Or in class, that's even more obvious. So today, Wednesday, this concept will come up again and again. It'll come up when, as Alex alluded to, when we have gases and we change them from liters of gas to moles and blah, blah, blah. It'll come up when we have solutions and we have to change the amount of solution with its concentration to moles and so on. But you know what? However we do these, folks, we're going to go in and out of moles for all these different problems. But this is one of the basics of AP Chem, is limited reactant problems. So questions on this idea before we continue? You have a question?
Well, just for the quiz, will it also be on how to find the mass of the chemical in excess? Or like how much is left over?
I could ask that, but I didn't hear. And frankly, I don't want to say I don't want to waste 45 minutes on a quiz, so I'm not going to have you do that much calculation. I just don't have the time to do it.
How many problems are there? Just one?
Yeah.
Oh,
It'd be like this.
okay.
Right. And make sure you understand it in addition to memorizing the mathematics of how to do it, okay? Understand as well. All right. Good. Okay. What I'd like to do today is some chapter 5 stuff. But before we do that, let's clean up the chapter 4 problems if you have some you want to ask about at this time. That includes Alex. We'll take questions on chapter 4. Then we're going to talk about atomic models and review those a bit in chapter 5. Okay, I'm going to make a little board space, maybe the top one, bottom one. And okay, so chapter 4, some suggestions that we want to look at together. Let's see.
Page 231, number 32. It was the one asked about in the chat, and I followed your instructions, but I still got a different answer from the answer sheet. So maybe I'm doing it wrong, but I just wanted to.
Let's find out. And once we read it, I'm going to have you tell me what you've done, and we'll see. Okay, so 13, we did this a little in the class chat. I gave you some ideas. And we're supposed to find the mass of the sample of octane burnt, combusted, in the calorimeter. And I could be wrong. Let me read it again and see what I suggested to you and how to do it. Okay, so octane's burnt, and I've got the delta H of combustion. And it's for octane. It's the only stuff in the problem, so I'm going to leave that. Okay, let's do our initial and final. So Ti for the calorimeter, 21.002 degrees C, and the final 27.014 degrees C. And then the heat capacity of the calorimeter. We want the grams of octane burned. Okay, let me just check one thing before I get back to Alicia and see what she did. That's really, I think, what we gotta do. Okay, what did you do?
You take the capacity of the solar calorimeter times the change in temperature.
So let's look at that. For everyone, look at the labels. That's really the important thing. They're often strange, but they should lead you to the right answer. This is kilojoules per degree C. So we're going to clearly have to multiply by that, by degree C, to get kilojoules out of here. So we're going to get some amount of heat. And I don't know any other way to do it than that. So I'll ask Alicia again, what did you put in and what did you get for an answer?
So I put in 10.45, which is the given value for the capacity, times 6.012 to the change in temperature.
Okay, and?
I got 62.82 and then 54.
Yeah. What label?
Kilojoules.
Okay, so let's get somebody else's help from there. I need grams of octane burned. What can I do with this amount of heat? Actually, now that I think about it, it seems like there's no, there's only one way to do it. There's only one way to do it. Yeah, okay. What's up here?
We could change the visuals to drills and visuals to.
Yeah, let's do that. So first, let's mentally do that, everybody. That many kilojoules, I have to do what mathematically? How about m to me to get it into regular joules? That would make it a small number of kilojoules. Multiply. You've got to get used to that. Kilojoules contain a lot of joules. So 62,820 joules. Okay, good. And then Anne-Sophie says we need to change, essentially, here's our plan. Joules to, one more time, Anne-Sophie. I can't do that right away. Hint. Here's my label. Ah, so joules to.
So joules to moles and then to
Joules and then 2 grams. And I screwed up, didn't I? I could have left it in kilojoules, couldn't I?
yeah.
Oh man, okay. Normally they give you these in joules. Okay, never mind. So then, and I assume you did this as well? Let's see, she did. Okay, so in which case the book may have the wrong answer, or I may have forgotten something. One of you is going to find my mistake. Okay, so guide me through it. How about Feeny? What can I do here? What numbers are going where?
You were going to catch me off guard, but the joules, wait.
So what have we found for our amount of heat?
63.
Good. And essentially we're going to use Anne-Sophie's plan. So boom. Yeah.
Moles on top.
Yep.
And moles on the bottom.
Good. Somebody else, can you put something in this mole and kilojoule thing? How about Bella? Where's that piece of data that we can grab and use?
We know it's 90,074. We use 4 moles.
One, right? Yeah.
Is it not negative? No, because you have to put it. Oh.
You don't really need it to be negative, I think, for this problem. We should end up with a positive amount of grams anyway. Okay, the molar mass, right? The chemical is octane, C-A-H-A-T. So somebody crank that out, Nina. 140, like that.
142.
142. I'm sorry.
114.
Oh man.
I'm
Okay,
sorry,
one-
am I the math?
It is the mass. Like that.
Yeah.
Thank you. Thanks for persevering. I'm sorry I can't always hear with our mask on here. Okay, so did you have the same molar mass too? Listen.
Yeah.
Okay, so we should get the answer, and then let's think about it and see if it's the right answer. I can't think of any other way to do this problem. Unless one of you do or have. Have any of you done it a different way and gotten the correct answer that was on whatever file you have for Cheryl Smith's answers? Okay, then I'm guessing this will lead us, listen to the correct answer. And I don't know if I'm wrong or if she has a mistake. Sometimes she has a mistake in the answers and we catch them. Then I'll leave it at that. When others get to that, if you find a different way to do it and you understand that I've made a mistake, please let me know. Okay? All right. Let's take other suggestions from you. Aiden has some.
I'm just confused about assigning the oxidation state.
Mhm.
I was
Let's do one or two to kind of see how to do it. So you got a page so I can work some?
182.
Mm-hmm. Let's do a couple. So page 182. Hold on just a second. Okay, page 182, is there a specific one that some would say?
Specific to the number two.
Specifically number 2. Okay, so. Is that the puppy? Okay, so assign the oxidation of each atom in the following species. Okay, they're getting a little tricky here, okay? Li is in what chemical family or group? I know I don't usually ask that. Where is it on the periodic table? Here?
Alkaline level?
Yeah, and they pretty much always have what charge? Plus. So Li is plus. O2 is kind of a stinker here, right? You might think it's like, hey, great, it's a peroxide, so it's O2 2 minus. Remember that from our ion quizzes? That's the deal. So that's what makes this one more challenging. So in essence, if I've got 2 of them and they're each 2 minus, then what will be the charge on each one? Yeah. Are you with me? Let me say that again. I got 2 of them together, they're 2 minus. So if I just have one of them, it would be 1 minus. Make sense? That's all there is to it. And we didn't use all the rules and stuff there, Aiden, because that one with peroxide, I can't use the rule that O is usually 2 minus. Because if I got peroxide, it's not 2 minus, it ends up being 1 minus if this sucker is peroxide. So let's do another one where it's not an exception, but that one is. And the only way, Aiden, I know that is Li from that first family, they're just always plus. Those Na plus, Li plus, K plus, all those guys. Before we do another, Anne-Sophie?
So basically, the only thing we have to do is this expansion.
No, that's what we had to do here. There's the longer way that I assume Aiden's asking about, and we did not have to do that with this problem. We'll pick one. Oh.
When we have a compound 3 elements, it uses as an sample problem, it sets it up in sort of an addition.
Yeah.
So equals 0. So
Exactly.
are you only ever finding the oxidation state of the middle element through doing that?
What do you mean middle element?
Whichever element in the middle. Because that's what
I'm looking at an
you're
equation.
saying.
There's only 2 elements in each chemical, so I don't really follow what you're saying. Specifically number 3?
Number 3 and number 4.
They have 4 different or 3 different atoms.
Yeah.
Okay, it doesn't matter if there's 2 or 3 or 5 or 100 atoms, by the way, okay? You just do them the same way. Let's take a look at 3, all right? So 3 says, I want the oxidation number of each ion. I got AgNO4. Okay, so here we go. Some of them can vary and some really cannot. The Ag really can't. And I don't know how you're going to know that. What's the charge on silver from the ions? It is 0. So 1 plus for that guy. Now the rest of it's going to add up to 0. So what do we got? We got 1 plus. The O's, now we're going to do it in the longer way, where where Cheryl Smith says that we're going to assume each O has what charge. Exactly. So we're going to say 1 plus 4 O's, and they're each minus 2 or 2 minus, plus the one we don't know, the Mn. We don't know it. I'm going to put Mn.
That's what I want.
But it doesn't have to be.
Why don't we know?
Because our assumptions are, other than peroxide, which is a pain, our assumptions are that O's are going to be worth 2 minuses and H's are going to be worth 1 plus.
Why can't we make that same assumption?
Because it varies a lot. That's why if you look at the rules that they give you, Mn is not in the rules. Because we really can't assume that. So the rules are on page 180, and the only really ones we can assume are O is 2 minus and H's are plus 1. And that if there's no charge on the whole thing, then it all adds up relative to zero. But I don't like the idea of just trying to memorize, oh, it's the middle atom. Well, it's not always the middle atom. What if I wrote it like this? MnAgO4. Well, then it would be now the first atom. You know what I mean? So just find each one that you can.
I don't understand what content is. Why we know it when we use it not for AG and not.
All right, well,
But that's something that we have to eventually understand or carry with us. Or is there any sort of reason?
here's the reason. Anytime I got things that are in bigger ions, like this one, like you recognize already, Bill, that this one you memorized and it's MnO4 minus, right? Anytime you got a metal in some bigger ion, that is often going to be something really different. That affects it when it's with a bunch of O's. Let's do an example and I'll show you what I mean. Here's two acids, H2SO4 and H2SO3. Clearly, who's going to be the problem here? Who's going to probably change its state? The sulfur. So the sulfur is the problem. The O's are still going to be 2 minus, the H's are going to be +1, but sulfur is going to be different, okay? So we got, let's run across it. We got how much charge for here, folks? Call it out. 2. So we got 2 times 1, +1, plus S we don't know, right? And we got 4 O's, so 4 times. Good. Okay, adds up to a total of 0. Good. Some of you solved that one. Okay, others help me with the next one. This would be 2 times 1 again, or 1 plus or +1, plus the sulfur, plus. There you go. And it adds up to 0. Okay, who solved the first one? What's sulfur's oxidation number for this one? Here, Oscar, pick one and figure it out. And let me know. We'll check and see.
I'll do the second one.
Okay.
So that's 4.
Good. So 4 plus. Right. The first one, Louisa? And that, just with doing the process over and over, is how I do it, baby. So use those rules and use this idea. That's what they're showing you with the math, that it just all adds up to 0. It doesn't have to add up to 0. Watch this here, Bella. I can do the same thing with this guy. I could do 4. I could do this. Well, it adds up to -1. And then I just do, I don't know what the Mn is, but I know I got 4 times 2 minus. So I could do, it doesn't have to add up to 0. It adds up to whatever the charge is. If there's no charge, it is 0. Let's take your question. Answer.
So for AG and MnO4,
Yeah.
would it be 7?
Did we get that far? I don't know. Is that what it is? Well,
Is it
now
allowed?
it'd be -8. Yeah, that's right. 7. Yeah, 7 plus.
So it could go as high,
Sorry?
so you could go, it could be like a high number, like 14.
No. 7's pretty high. 7, 8. I don't think I've ever seen anything 10 or more, so that'd be unusual. Okay, we'll answer another question or two when we come back. Take a break. Alex, if you got any to ask about, type them out and we'll do those too.
I'm confused about this. For some reason, this drawing threw me off. I got the recipe to get the answers to try and understand, like, backwards, a little bit backwards.
Yeah.
Okay, so that's usually reactive with an extra. How would I know that without doing
Okay, so this is your like recipe. This is what's in the cupboard. Well, in the recipe, I got 2 to 1. In the cupboard, I got 4 and 3. Well, that's not so good. So I got to like do what? Well, if I double that, and I get 4 of those, and if I double that, So I'm able to make how much of the product. Yeah, plus.
Wasn't it like also like
Just the ratio.
Oh. And I was like,
Let's make sure you know.
I was
So
asking
I
around.
got 4 of those, ideally I would want like 2 of those, right? But I got an extra one. So this chemical is gonna be in, that's going to be my limiting one.
Okay.
So now these the ratio, it's 2 to 2, so if I got 4 of those, I should make how much product?
Wait,
Two to 2. It's not about adding, it's about the ratio. It's just 2 to 2.
You made it yourself, right?
Yeah.
So if I got 4 of those, I got 4 of those.
Okay.
She's really good at like.
Oh,
Wait, you made that yourself?
well, no, I
No,
know.
she's really good with.
I got 2 COs, and 3 of these guys, and of course one is left over, right?
Okay. Yeah, okay, thank you.
You're welcome. Okay, gotcha, Alex.
I can't, like, I don't have, any water with me, and then, like, I was biking and I was like, I really want like that was a long time. And I was like, ah, and I was like next to the back gate and I was like, shit, I forgot my face back. Like, oh my mom and I biked all the way home. And then I biked all the way back to home and I was like, ah, I need water. And then I was like, no, not bad.
That's what I'm scared of. I'm scared of being not working.
No, you have to buy them for €2 for the growing ones. Apparently, but I didn't know you could. And I used to have face masks in my locker, and then like, you know, to throw the ones, and then you have to go home. So I was like, I don't know how long we're gonna stay home. So I got everything with home with me. And then,
Me for math. Really about them. Like I probably have it 3 times already. Sure.
my mom, she came outside and she put a face mask.
Oh, my family is in softball. Yeah, but like I feel like I would just be later.
Well, I was really worried about this one because it's really, really thin, and then I kept going. I can't control it.
Yeah.
Yeah, I saw this test, like this guy took this test with like a bunch of different face masks, and I was like, Mom, I'm gonna steal your face mask and use this.
No, I'm nervous. We had a math quiz morning, and we did. I thought it was fine. Yeah, I thought it was fine. But now that I think about it more, what's it about? Which is actually like pretty easy. Harder. Yeah, like I just think I messed up. So, yeah.
Yeah, my sister had a lot of fun.
Like he doesn't cut homework. Yeah.
Like, doesn't get, we're all.
It's not like theoretical. Yeah. I feel like it's before,
But my sister, when she took his class, like when I was like, there were like these 2 guys, and like the end of the year or something, he was like, oh yeah, let me just look at your homework, you guys want to turn it in. Literally printed out his answer key and turned that in.
I mean, he wasn't really checked the correctness at all. It's just like it's not like whether you did it, yeah.
I think I like 100%. We're turning in his answer key.
But like again, he's more like it's the homework is like that you become better. It's like not care.
My sister was really scared back then. And then she was huh? Yeah, she was tackle us in 11th grade, and she was like really worried about the like because she was having a hard time. And then she was like, I'm gonna study and I'm gonna do it. And she failed her review quiz.
Why are you putting it in the
And she got like full points on the AP quiz exam, and she was like,